So then these next two sessions are pretty closely related. We sort of divided them up in terms of the agenda into assignments and then class activities. But the truth is that many of these, perhaps even most of them, are appropriate to do with both some in-class portion and some out-of-class portion. And I think in particular, to reinforce the ideas, some class discussion that references, if a large part is done out of class, some class discussion is really, can be quite an important part of reinforcing what's been learned and what's been grappled with. So, and we're going to kind of move here. Ben and I are going to split this these two sessions, starting with simple examples and moving to some more complex frameworks that actually, perhaps give you more freedom, more creativity with respect to the kinds of assignments or activities you might do. The early ones are pretty well structured. And we're thinking you might use these directly. You might think about some modest adaptation, or you might use them more as a sort of springboard for creative thinking. We'll share these slides. This question: do our students want this? This Twitter, this tweet plus. Actually, it's a series of tweets, is from one of our very best undergraduate students, Jordan Taylor, who is about to start a PhD program at CMU. And he walks through every one of a whole set of our undergraduate classes saying, here's how ethics could have been embedded in this class. So at least a subset of our students are really asking for this, and Jordan's quite a thoughtful student, and I think his take is well worth having a look at. So I'm going to walk through 4 examples, and they're sort of increasing in their level of I guess complexity, and also in sort of the type of course that you might use them in. I would say that the first 3 are coming from outside of Georgia Tech. The last one is one that we have developed within Georgia Tech. And everybody who's made these available, from outside is really, I would say, eager to have others take them and use them and modify them. So, and there are links provided in the talk so that you can see what those are. So the first one is this, has to do with building algorithms that can help with hiring. And the thing I really like about this activity, and apologies for, the thing I really like about this is a couple things. First of all, the designer here has outlined, here's what the programming objective is, and here's what the ethical objective is. So very clearly, this is a activity that is going to teach some programming, nested for loops here and 2D lists, and is also going to have an objective that has to do with reflecting on trade-offs. So a little bit to Justin's point about recognizing issues, this is not an activity that asks for the perfect algorithm for resume screening, but instead ask students to design an algorithm and then think about what did they include and not include in terms of applicants. So, it's a nice setup that, of course, hits really close to home for students. You're hired to a company. You're going to create a program that will select which applications would get a second look, presumably with more human intervention. So the algorithm will filter a number of applications out, and then the others will be forwarded. And simple setup, but definitely plausible. They collect data about your computer science classes, the grades across 6 core classes and overall GPA. And then that gets stored as a list per applicant. And so, a set of classes that would be typical in almost any undergrad CS class. And, here's why we don't want to do it. Here's the reason why automation is being considered. It's lots and lots of students. And then, this is set up to be done in class, could be done in small groups. Of course, you could also assign it to be done outside of class. And basically figure out how you're going to select the top applicants, right? Then there's some coding, write a Python function that returns a list, and be able to say something about the trade-offs. There's some support material here, a list of applications, and then some additional applications that have some interesting cases. So then the kind of key piece here is, after the students have worked on the algorithms for a bit, then you talk about what criteria did you select and why? What kind of applications were you trying to have succeed? And then it turns to, what kind of applications would you have missed, meaning you filtered them out? And starting to connect this to a set of stories about applicants, some of which are kind of in some sense straightforward, right? Range checking, misinterpreted the instructions, put in -1 because they didn't take CS1, made a data entry error. But the last two are actually of quite different character. So, what if there's a student whose trajectory is generally in the upward positive direction, or a student whose trajectory is generally in the downward direction? How would you compare those? Of course, they'll have the same average, but they look very different from a trajectory point. And then one, that no doubt many of our students can relate to, overall quite strong, one semester, one course with a much lower score. And so, that leads to these questions about, what does it mean to design a fair algorithm? What happens when we trade, give over some human processing to machine processing? How, there's a goal here of efficiency. How should you make those trade-offs between efficiency and doing a better job or a good job in picking applicants? And then systemic advantages and disadvantages, to the point of who might, for instance, be disproportionately harmed by choices that are made in the algorithms. And as this says, not like we have the answer, but it prompts reflection, and that is quite valuable. So now let me see if I can return to my slide deck. Hopefully you see this. So that we have used that example, shown that example in a train the trainers with the TAs, and what I really like about it is how close to home it can hit for students. And also, as you can see, it's a relatively simple activity, could fit very well in an early computer science. The next two are for classes that would be more in the CS2 or perhaps even a little bit later type of class, and they both come from real world, very closely coupled to the real world. So the first one, of course, has some plausible relationship to the real world. These actually use real world data sets and concern very, I would say, relatively higher stakes issues. I'm getting a job as high stakes, of course, but these next two have to do with criminal justice and then with voting. And these have both come from a collaborative group based in the University of Utah and Haverford College. So this one is about the creating risk assessment. So recidivism risk that someone who's been charged with a crime would be a repeat offender. And this is, of course, based in this is done in practice. And as I said, has fairly high stakes. A thing I really like about this setup is the collection of materials that are provided. So there's a video. Let's see. There's a ProPublica article about how the setup is that two different offenders were rated very differently in risk. One was an African American woman, the other a Caucasian man. And in fact, going forward, the woman who was rated as a higher risk had no further interactions with the legal system, while the man who was rated as a lower risk did. And so it talks about how the algorithm worked that assigned risk to individuals. So there's a video, there's an article, there's a background video made by a Haverford student, which I think is a wonderful addition to have students talking to students about these issues, and then some additional detail. The assignment is a two-part assignment, as you can see, and it uses some data, and just to briefly kind of walk through a little bit of this, it's here's the ProPublica lab, right? And it's a set of resources, and then it walks students through how to create classes, methods, constructors, all the things that we want to teach students in data structures, and then eventually you replicate the analysis. So you figure out things like what it means to count for based on race whether you should be high risk or low risk. So so this goes on, and eventually there is a step where you replicate the ProPublica results. The second one that comes from this Utah and Haverford group, I like because it's actually connected directly to voting rolls and to voting in Georgia. So, anew to your question, this is probably the one that comes the closest to having a basis in politics. So, what's cited here is the 2018 election in Georgia, where an exact match rule was instituted. And if you didn't have that, then you had to have a local registrar do verification. So there's an article that appeared in the Washington Post that explains what this was, and there's a data set of voters, a voter roll data set. And the assignment is to detect duplicates. And so you have to define what it means for two entries, two voters to be the same voter. And there are a variety of methods that the assignment takes the student through. So including using a hash function over particular values in the voter, in the fields that identify voter information. So using a hash function, sorting and comparing. In all cases, there has to be a comparison at the center of it. This one this activity also ties in energy usage. That seems to me, that's sort of optional. You could do the data deduplication component of it and set aside the question of energy usage. This particular assignment expresses complexity in measures that connect to watts and to energy. So it actually has a sustainability component. It has a complexity component. And then it also has this idea of how do you determine if two voters are, if two voter entries are for the same voter. And I think this one, one of the things that's interesting here is issues that arise, for instance, because of common names within different nationalities, right? And so, in some cases, it's very easy to say, if it's same first name, same last name, same address, must be the same person. But In some cases, there may be multiple people with the same first and last name and same address living in the same household who are two different people. So it starts to raise the importance of thinking across everybody, not and recognizing that if you make a certain set of decisions, you may in fact systematically change the outcome for a certain set of people, based, for instance, on ethnicity or of names, which probably isn't what you want to be doing. Well, so that's a second example, also out of this Utah group. The last example I want to share is one that we have developed here at Georgia Tech through the Mozilla funding, and we've used this in several different classes. So the first three were very closely coupled to to teaching programming, to teaching data structures, to introducing students to algorithms. This is quite different. It's a role play activity where students get into small groups, each taking on one of up to 9 roles, and you can do this in parallel, multiple student groups at the same time. And the setup is that they are participants in a community meeting for a city trying to decide whether to use self-driving buses for public transportation. Take part in a trial to use self-driving buses for public transportation. And there are a set of trade-offs about doing this. And the students each are given some information about their role, and then they need to try to make a recommendation about whether or not they think the city should proceed to participate in this activity, in this pilot, this pilot situation. And you can see from the stakeholder roles that it's a mixture. There are some that are technical roles, a HCI expert who comes from a local university, someone from the cybersecurity field, a computer scientist from inside the company that is selling these self-driving buses. And then there are people whose interests would be, who do not come from a technical background, but who have other stakeholder interests in the outcome, including a chief innovation officer for the city, who, for instance, might be quite supportive of the idea of this city doing something that seems to be on the sort of leading edge of innovation. There's also a bus driver union representative, so someone representing a group of people whose jobs might be lost or certainly transformed by the introduction of self-driving buses. Something that's been interesting when we've done this role play before with students is that the students are a little, perhaps a little more reluctant to take on the technical roles than they are to take on some of the other roles. And it's somehow an interesting statement that they perhaps they know that what they don't know about being a technical professional, which makes them a little bit reluctant. And yet for some of these other roles, they are very comfortable, seem to be quite comfortable, taking on these, bus driver union representative, for example. And we have seen the full gamut of recommendations come out of these conversations, from absolutely, full steam ahead participating to, we should not do this. We should just not do this. And the conversations that happen in those groups are of course what's kind of at the heart of the activity. So letting students talk through, what are the safety considerations? Who would be impacted by this, and in what ways? Where do we see benefits, and where do we see that some particular people would lose something in this? And there's also an encouragement to think about ways to reach, to structure it so that you try to achieve some balance in terms of harms and benefits. And the students are, are creative about thinking through how they might preserve some of the benefits of moving to self-driving buses while offsetting, in particular, the concern about future of work, and the bus driver future of work is very prominent in their minds. And just so you have a sense here, I wanted to show you that on the website for this, we actually have there are actually 2 activities. So there's a second one that you could take a look at. There's quite a lot of support material here for using this in a classroom. There are descriptions of all of the roles. There's a teaching guide to be used that you can use to help structure how you do this and how you run the decision making. There's even some materials that including name tags, which we found useful because the students can't keep track of who is in what role. So there's quite a lot of support here for doing this activity. And the second activity, just to give you a little pointer, is actually a bit related to the hiring algorithm example, and it's about a university considering using an app that would help out, use AI to help with admissions. So again, hitting close to home for students, and also tapping into current events such as the use of HireVue, the company HireVue, for making decisions about hiring.